Let's think about vertical asymptotes of rational functions. So a rational function that has the form p of x over q of x, so again, p of x and q of x are polynomials with real coefficients. This has a vertical asymptote at a number c if q of c is equal to 0, but p of c is not 0. So let's see some examples of rational functions with vertical asymptotes. The function 1 over 1x minus 1 is a rational function. Here p of x is 1, q of x is x minus 1. This has a vertical asymptote at x equals 1. If you plug in x equals 1, the denominator, the bottom, is 0. If you have a vertical asymptote, that means the graph of the function looks like this. So at x equals 1, there's a barrier almost that the graph of the function cannot cross. So there's x equals 1. I'm drawing some barrier. The graph of this function is similar to the graph of 1 over x, but just shifted. So this is the graph of the function 1 over x minus 1. The vertical asymptote is here. Let's do a couple more examples. What would be different if I wrote down 1 over x minus 1 squared? Well, there's still a vertical asymptote at x equals 1. But this time the behavior is a little bit different. The graph of this function looks like the following. Here's 1. I have my asymptote, my line the function cannot cross. If I plug in a number that's close to the asymptote, but a little bit smaller, like if I plug in 0.9, then this function is positive. If I plug in a number that's a little bit bigger than 1, like 1.1, this function is still positive. So this function is positive whether you're on the left or the right of the vertical asymptote. That means the graph must go something like this. If you look at our previous example, this was a little bit different because if we plugged in a number a little bit less than 1, like 0.9, then this was negative. That's why the graph went negative as you're on the left side of the asymptote. Let's do a couple more examples of vertical asymptotes of rational functions. What would happen if I had 1 over x plus 1 squared times x minus 2? So I'm going to draw this graph over here. I have vertical asymptotes in two locations. I have vertical asymptotes at negative 1. So if I plug in negative 1 into this function, then I'm dividing by 0. So over here I'm at negative 1. There is a vertical asymptote. And also at x equals 2. So at x equals 2, I have a second vertical asymptote. You could determine the behavior of what happens near the asymptote by plugging in values close to negative 1 and 2. So if I plug in a number that's close to negative 1, but a little bit smaller, like negative 1.1, I think you'll find that this term is positive, whereas this term is negative. So numbers to the left of this asymptote are negative, meaning the asymptote must be getting smaller and smaller here. If I plug in a number a little bit to the right, like if I plug in negative 0.9, this term is positive still. This second term is still negative, so the whole term is negative. So again, if I'm on the right of this asymptote, I get a negative. So it goes like this. If I want to determine the behavior around 2, I could do the same kind of logic. So I can plug in a number like 1.9. I think you'll find a negative. If I plug in a number a little bit bigger than 2, I think you'll find a positive. So the graph actually behaves a little something like this. Okay, let's finish this video with one example more. How about the function x squared minus 1 over x plus 1? This function actually does not have any vertical asymptotes. Why? Well, it looks like that minus 1 is a candidate for an asymptote. So minus 1 makes the bottom 0. But if I plug in x equals minus 1 into this top function, I also get 0. That means I do not have a vertical asymptote. You can see what's happening if you factor. So the top has a difference of squares, x minus 1 times x plus 1, and the bottom is x minus 1, or excuse me, x plus 1. These terms cancel, and it looks like I get the function x minus 1, but we have to remember the domain. The domain of this original function was all values x except for negative 1. So I have the graph of the function x minus 1 except at one value. So this would be the graph of this function. I have no vertical asymptotes. This is almost the graph of a straight line. It is a straight line, except at the value negative 1, I get a hole. So here I have a hole, and other than that, I have the graph of a diagonal line. Okay, wonderful.